Greetings. Welcome back to Math 106. I'm going to talk about the trig functions and our trig toolbox, as I like to call it. And I'm going to walk through the several pieces that are in the handout that are included in the module for the right triangle trigonometry. The second page in the handout looks like this. And this video is going to focus on what is on the second page here. I'm actually going to switch over to my document camera so that I can write some things down and you can kind of follow along, but that handout also is going to follow what I'm going to write down for the most part here on my whiteboard. So let's go ahead and get started. So what we're going to start with is, and what we're going to create and use over and over again here is what I call the trig toolbox. So here's our toolbox. And we've got some things that we're going to put in our toolbox. Okay. So the first thing is something that applies to all triangles. All triangles, no matter what they are, whether they're a right triangle or any other kind of triangle, is that all the angles, so we're going to call, there's 3 angles in a triangle, right? We're going to call one angle A, that's the little symbol for angle. Angle A plus angle B plus angle C, those would represent the 3 angles, all equal 180 degrees. And this is for all triangles. So just stars calling our attention to the fact that it's all of them. So a lot of the things I'm going to talk about are specific to 90-degree or right triangles, but this one in particular is for all triangles. So then we're going to switch gears just a touch and we're going to say, okay, that's all of them. Now let's look at things that apply to right triangles only, without exception. So the next few things I'm going to put on here are going to apply to right triangles only. And if you have a different kind of triangle, then you cannot use these. We would have different tools for the triangles that are non-right or what's called obliques. So the first one you may have heard of before, and it looks like this. It's c squared equals a squared plus b squared. And that is what we lovingly call the Pythagorean theorem. Right? C squared equals a squared plus b squared. So that works. And we're going to find out here in a little bit that the C, the A, and the B here are representing sides of the triangle, where up here, the angle capital A, angle capital B, angle capital C, I'm using to refer to angles. So angles are capital letters, sides are little letters. That could change. That's just the symbolism I'm using to explain this, and it's also what's reflected in the handout that's in the module. So you could run across things where it's a little different than that, but that is how I'm going to explain this. I'm going to stick with that program. Okay, so next what we have are what we call the trig functions. So in a separate video, I also kind of explain where the trig functions come from. And also there's also supplemental resources from Khan Academy included in the module. And all of these are really focusing on what we call the trig functions. So we have a mnemonic that you may have heard of before that is called SOHCAHTOA. And SOHCAHTOA, you may have run, if you had trig in, say, high school, or you've had some trigonometry in some other walk of life, you might have run across SOHCAHTOA. And so I'm going to try to color code it a little bit so we can kind of call attention to the pieces of SOHCAHTOA. Okay. So the mnemonic works like this. We have S, O, and H, that's the so. And then we have ka, SOHCAHTOA. So ka is C, A, H, and ta is T, A, H. What the heck does that mean? If you've never heard of it before, that might sound a little weird, but this is basically shorthand so that we can remember what the trig functions represent. So to define these, we're going to draw a triangle, and the triangle looks like this. So we've got a triangle, and it is going to be a right triangle. There's one in the handout again that also reflects the same idea. So this little box here is telling us that this is 90, right? That's 90 degrees. So you don't have to write 90 in there. The little box just denotes that that's a 90-degree angle there. So we're going to label this triangle with the ABCs that we used to define the 180-degree rule, and then also to define Pythagorean theorem. So we're going to go ahead and put some labels on here. So this is going to be my angle A out here. So that's referring to this angle here. My angle B is going to be up here, and angle C is always going to refer to my 90. All right. And then the sides are going to be across from their corresponding letters. So the side that is across from A is going to be little a. The side that is across from capital B is going to be little b. And the side across from the capital C angle is going to be little c. All right, so we've got our letters on here. So now you see we have capital letters at the angles, and then smaller letters reflecting the sides. So again, this is just one way to lay this out so that you can understand it, but it's the roadmap we're going to use over and over again in here. All right, so let's go back to SOHCAHTOA. So now that we have a triangle that's labeled, and we have SOHCAHTOA here on the left, let's find out what that actually means. Well, the S here stands for sine. And the thing to remember about the functions is they always need to have a perspective. Okay, and what I mean by that is we have to label where there's perspective or where we're looking from. So I'm going to put a little stick figure person here at A. And I want to put a different little stick figure person here at B. Let me find a different color. So B is going to be green and A is orange. All right. So the first trig function, the sine function, is first going to be from the perspective of A. So we're going to have sine of the angle A. And all that is really the sine represents a ratio relative to that angle that is opposite. So my O stands for opposite, and my H stands for hypotenuse. So it's opposite over hypotenuse. Okay. So sine A is the ratio, sine of the angle A is the ratio of opposite over the hypotenuse. And that's referring to length of side. So that would be equal to, okay, from the perspective of A, so I'm the little orange stick figure. From A, when I look across the triangle, which would be, across would be from this angle, looking across the triangle, the opposite side from angle A would be side little a. So this would be A. The hypotenuse never moves based on perspective. It doesn't matter if I'm the orange stick figure or the green stick figure. The hypotenuse is always going to be little c. So that does not change, stay static. We'll see. All right, so we've got A over C. So there, the sine of angle A is side A, the ratio of side A to ratio of side C. All right, so sine B then, sine of angle B would be equal to the opposite side from the perspective of B. Now I'm the green stick figure. I'm looking from B. Well, from that perspective, the side that is across or opposite from angle B is little b. So here I have, again, it's opposite over hypotenuse. The difference is where from? Well, now I'm from B, from the side B. My opposite side is little b. So now I have little b is over the hypotenuse, which does not move, and that's C. So we see the only difference between the sine A and sine B is which side is opposite from the perspective of that angle. All right, so that's the sine function. So sine A opposite over hypotenuse is A over C. Sine B opposite over hypotenuse is B over C. And this is lengths, and the capital letters are angles. All right, if we can do that, then we can totally do cosine, because cosine works pretty much the same way. So for cosine, I have the same situation. I have cosine of A and I have cosine of B. So I have both angle A and angle B again. So I just change perspective. Ka, so ka is A and H. The A stands for adjacent. So this is adjacent. I'm going to abbreviate that as ADJ. It's adjacent over H, which is the hypotenuse. Well, the cosine of B is also adjacent over hypotenuse. However, again, like we saw up with sine, adjacent is with respect to angle A or angle B. So in the first one, cosine A, now I'm the orange stick figure. I'm at A. I look at the two sides that make up the angle A. We've got this side here. Well, that one already has a name. We call that the hypotenuse. This one down here, this one, which is not the hypotenuse, is what we would call the adjacent side to angle A. So little b, from perspective of A, where my orange stick figure is, little b is adjacent, or another way to say this is next to B. So my adjacent side from angle A is little b. My hypotenuse does not change. That's always going to be C. So got C. Now cosine B from the perspective of B, which is my little green stick figure here. From B, I'm going to make this a little bigger for us. There we go. From my green stick figure, what's my adjacent side? Well, just like down here at A, I have two sides that make up angle B. I have this side and I have this side. Well, this one here is already C, that's already hypotenuse, so that's just the hypotenuse. You cannot have it be two things at once. So that means that this side here is my adjacent side from the perspective of angle B. So if I come back here to my cosine, that means that my adjacent side is little a. So I have A over the hypotenuse, which is C. All right. Last piece of our SOHCAHTOA then is the tangent function. So tangent works just the same way with one slight difference. We gotta make sure we have the right letters to start with. I think I'm gonna use red for both of them and hopefully it'll make sense why here in a second. So we've got SOHCAHTOA. All right, tangent is abbreviated TAN. And it can again be from angle A or angle B. Okay, so tangent function has the same sort of behavior, but one little difference. It doesn't end in H, right? So TOA has an O and an A. So tangent is equal to the opposite over the adjacent. So it's two sides instead of one side in the hypotenuse. Tangent from B is also opposite over adjacent. The only thing that changes is perspective. So if we go up here and we look, tangent A from the perspective of A is the opposite side. Well, opposite to angle A, across from it is little a, right? So we have little a. And the adjacent side is then on the bottom. So from the perspective of angle A, the adjacent side is little b. All right, cool. Tangent B then is opposite over adjacent, but it's from the perspective of angle B. So we go up to our little green stick figure. And opposite B is little b. So that goes on the top. Adjacent to angle B is little a. So you see the only difference between tangent A and tangent B is that one is the inverse of the other. So tangent is the ratio of the two sides of the triangle. Sine and cosine is the ratio of a side, a specific side, to the hypotenuse. So these are all the sine, cosine, and tangent trig functions, or trig ratios as they are sometimes referred to, that we will use to solve problems here in a little while. All right, so the last thing we need in our toolbox, I'm also going to write under here, A, B, and C are angles. Little a, little b, and little c are sides. Okay? The last piece of the puzzle that we need to really be able to use these trig functions effectively, I'm going to put down here on the bottom, and this is the reverse of any of the trig functions. And these are called inverse trig functions. And they are also, another way to think about them is that they reverse, if I would spell it right, reverse the trig functions. All right, so if we can reverse, it is similar to what we did with the square and the square root, or the cube and the cube root. So we need a way to go in the opposite direction. So the inverse trig functions look a little different. They look like this. That is sine, sorry, having a little trouble with my black marker. Sine minus 1 is inverse sine. This is the reverse or undo button for the sine function. So the inverse sine, or sine minus 1, of sine A is equal to A, because this cancels out this. And all we're left with is angle A. So then cosine -1, or inverse cosine, reverses cosine. Let's say B this time. That's going to equal, can you see? It's going to cancel out my cosine, cancel out my cosine. That's going to equal B. All right. Then the last one is tangent. Tangent, inverse tangent, or tan -1, is the reverse of tangent of either A or B. Let's go back to A. That would cancel out the tangent function, or reverse or undo it, and we would be left with just angle A. So the inverse functions we use when we want to solve for an angle. So that's important, and we'll use these as well to reverse the sine, cosine, and tangent from above. All right, this will make a lot more sense probably after we do some examples. I have a subsequent video that works through the practice problems 5 through 10 so that you can follow along and try those out as well. Hope you enjoyed it. See you again soon.